Alright, good day students. You're welcome once more to my channel. In our last lesson, we looked at set theory. In this lesson, we shall be looking at the types of sets, and then we'll proceed into the relationships of sets. So quickly, we shall be looking at the types of sets. The first type of set that we have is a null set, or it is also called an empty set. I remember I mentioned this in our last class, and in this class we'll now explain what a null set is, or an empty set. It is mostly represented as this, without any element inside. Now, once you don't see an element inside the curly bracket, it is a null or an empty set. Now, please take note. If you see something like this with a 0 inside, this is not, it is not a null or an empty set, because 0 is an element. Take note of that. 0 is an element, so it is not a null or an empty set. An empty set has no element inside the curly bracket. Don't forget this. Alright, the next thing we shall be looking at is a finite set. What is a finite set? A finite set is a set whose elements can be counted. So for a finite set, we can actually count the elements in that set. For example, if we are given a set of A, and they said A is a set of X such that X is an even number, less than 20. Alright, now set A is a set of X such that X is an even number less than 20. We can actually determine all the elements of this set A. So let's define the element of set A. So the element of set A is set of even number less than 20. So we start 2, 4, 6, 8, 10, 12, 14, 16, and 18, because the definition of this set says less than 20. Don't forget they say even number. You must remember what your even number is. Don't forget I told you that in set notation you must be able to define your algebraic terms. You must be able to interpret your algebraic terms. So now we've been able to interpret this algebraic term into the real definition of the element. So we brought out the element from this algebraic term. So because we are able to count the number of elements, we can determine the number of elements in this set. It is a finite set. Now we look at an infinite set. An infinite set is just the opposite of the finite set. An infinite set is a set whose elements cannot be counted. An infinite set is a set whose elements cannot be counted. Let's see an example. Example, if set A is defined as a set of X such that X is a multiple of 3. Now they've given us this. They said set A is a set of X such that X is a multiple of 3. We need to list out the element of set A. So my element of set A will be what? Multiple of 3. The first multiple will be 3. The next multiple will be 6, 9, 12, 15, 18, 21, 24. We can continue till infinity, because the multiple will keep going on and on. So this nature of set is an infinite set, because we cannot clearly determine the number of elements in that set. It is open-ended. All right, number four is a disjoint set. When do we say two sets are disjoint? Because for a disjoint set, you must be comparing between two or more sets. Two sets are disjoint when they don't have any element in common. No common elements. No common elements. Example, if I am given a certain set A to be set of even number less than 10, 2, 4, 6, 8, okay, less than or equal to 10, and a set B is a set of odd number less than or equal to 10. 1, 3, 5, 7, 9. Now, to determine if the set is disjoint, check the element in A. Can you see any element in A that is also in B? It is called an intersection. Is there any intersection between these two sets? The answer is no. So if you are asked to determine intersection, which I know we'll get to, the intersection between these two sets is nothing. It will give you a null set, an empty set. Remember, we defined what an empty set is. So because the intersection between these two sets gave us an empty set, these two sets are said to be disjoint. They don't have any element in common. Then quickly we'll look at the last type of set, which is an equal set. An equal set is a set that have every element same. It has every element to be the same, irrespective of arrangement. I will give you an example. Example, if I am given a set A to be 1, 3, 7, 9, and I am given a set B to be 3, 9, 7, 1. Now look at set A and set B. The number of elements here is 4, number of elements here is 4, and the elements themselves, 1 appears here, look at it, 3 appears here, 7 appears here, 9 appears here. So these two sets are said to be what? Equal, because their elements are the same, irrespective of arrangement. You don't have to arrange it the same way to determine equality. It's just to determine if the element in the first set is the same element in the second set. All right, quickly we shall be looking at the relationships between sets. So quickly, let's look. All right, now we are looking at the relationship between sets. The first relationship that exists between sets is what? The relationship called intersection. We just used it in one of our examples just now. Intersection. Intersection is written as this. This is the symbol for intersection in sets. Now, two sets intersect where the elements that appear in one set also appear in the second set. We'll now take example to explain intersection. Example, if I am given a set A, don't forget you always enclose your set with a curly bracket. I'm given a set A to be 0, 1, 2, 3, 4, 5, 6, and I am given a set B to be equal to 1, 3, 5, 7, 9. I want to look for A intersection B. Look at the symbol intersection. Is an N. Look at it, a small letter N. It's called intersection. Now, to determine the intersection between A and B, I'll be looking out for the element that appear in A that also appear in what? B. Now, let's look at the elements. 0. 0 does not appear here. 1. Yes, 1 appears here, so I'll pick 1. 2. 2 does not appear here. 3. 3 appears here, I'll pick 3. 4. 4 doesn't appear here. 5. 5 appears here, I'll pick 5. 6. 6 doesn't appear here. Once I get to the end, I just close this. So A intersection B is what? 1, 3, 5. That is intersection. Quickly, we look at the second relationship, which is what? Union. Union is written as U, small letter U. All right. Now, how do we define union? Union, to define the union of two sets, you just have to combine the elements in one with the elements in the other without repeating an element twice. Without repeating an element twice. So let's use the same example now that we have here. If we are asked to determine A union B, my A union B will just be I will just list out all the elements here and combine with the elements here. So let's list it out. A union B, I have 0, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6. I've listed all the elements in A. Now I want to list the elements in B. But remember that the rule is you must not repeat an element. So if I want to list 1, I've already written 1, so I won't repeat it. I want to list 3, I've already written 3, so I won't repeat it. I want to list 5, I've already written 5, I won't repeat it. 7, okay, no 7, so I'll put 7, and then finally I'll put what? 9. So we've gotten our A union B. Let's take one more example. Example 2. If a set X, don't forget your sets are always written in capital letter. If a set X is given to me as 1, 3, 7, and a set Y is given to me as 2, 5, 8. Let's look for X union Y. My X union Y will just list every element here, combine with the element here. So I have 1, 3, 7. Then I list this 2. Have I written 2? No. So I'll put my 2. 5. Have I written 5? No. I put my 5. Have I written 8? No. I put my 8. Now, irrespective of arrangement, but it's always good that you rearrange this. You can rearrange this so that it follows sequentially. So I'll have 1, 2, 3, 5, 7, 8. But it doesn't matter. Nobody will mark you wrong if you write your X union Y with this. It's still okay, but just for mathematical accuracy, you just rearrange so that it will be in ascending or descending order. All right. Now we've looked at the relationship. Now I'll be introducing you to what? A universal set. Quickly, we are getting towards an interesting part, which is Venn diagram, which comes out in every WAEC. So let's introduce ourselves into what a universal set is. All right. Now we're looking at the universal set. What is a universal set? The symbol for a universal set. Some people write it as, you see an E like this that has a head and a tail, or some people will write as a capital U, or some people will write as a capital E. Anyone you write is okay. Me, I like using this or a U for my universal set, capital U. Now, what's a universal set? A universal set is a list of all possible elements for a given set. A list of all possible elements for a given set. Now, once you've been given a universal set, they might not necessarily put a restriction on your other sets, but your mind should tell you that from those other sets, you cannot have a number that is outside your universal set. For example, if I am told that my universal set is all positive integers, all positive integers less than 12. Now look at this. They've defined my universal set to be a set of all positive integers less than 12. Now the question will come in this way. Then your set X will be my set A will be a set of X such that X is an even number. Now you can see, it's as though this is left open-ended. But remember that you have your universal set. And all your other sets are subsets of the universal set. So you cannot have elements outside the universal set. My set B is a set of y such that y is an odd number. You can actually use the same subscript x. Now, let's define our terms now. We need to first define our universal set. I say you can use a capital U or this, so that we can use this, but please be consistent in your own. Now, let's define our universal set. My universal set says all positive integers less than what? 12. My positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They say less than 12, so I'll stop at 11. Now, I've defined my universal set to be this, so I cannot have any other set, any other element outside these elements that I've listed. Now, let's come to A. My set A will be such that what? A set A is a set of x, so that x is an even number. So I'll list my even number. 2, 4, 6, 8, 10. If I mistakenly add a 12, look at 12. 12 is outside my universal set. So I cannot have a 12 for this question because I've already defined what my universal set is. So 12 cannot come in. You clean the 12 and you stop at what? 10. Then a set B. Let's define our set B. The set B is a set of y, so that y is an odd number. So let's list our odd numbers considering your universal set. 1, 3, 5, 7, 9, 11. Now you can see that the universal set already places a restriction on what your other subsets should be, what the elements in other subsets should be. I'm sure with this understanding, we will be able to go into a complement of a set, the difference of a set, and then we'll go into Venn diagram. If you've enjoyed this class, please click on the subscribe button so that you can always get updates on when our next video will drop. I celebrate you.